In this question, we're asked which compound could have produced the IR spectrum below. So we've been given these four organic compounds, and let's start off by drawing them just to make sure that we can identify what functional groups they have. So this first one is ethanol. The second one is a nitrile that has an alcohol in it as well. So we've got 1, 2, 3 carbons. There's a triple bond to the nitrogen on the end. And on this second carbon, we also have an alcohol. For compound C, we've got ethanoic acid. And for compound D, we have an amide, ethanamide. Okay, so IR is this analytical technique that transmits radiation of a certain wave of range numbers between like 500 and 4,000 wave numbers, and we measure how much of it is absorbed as a measure of how often a bond appears in that sample. So each bond has a specific wave number that it absorbs at. So for instance, this really sharp peak here around 2,300 is going to be because of a particular bond. And if we just have a look now, I've got the data table for IR from this question, and we can see that something around 2,220 to 2,260, I eyeballed this and said it was about 2,300, is a nitrile. So that's a super good place to start. Only one of our compounds has a nitrile in it, and that's B. But if this IR spectrum was produced by B, then we should also see this OH bond appearing for an alcohol, which is like a large, broad peak between 3,200 and 3,600 wave numbers, which we can see here also. So this is an alcohol OH group. So with those two peaks in mind, I think we can safely say that this is B. To rule out some of the other possibilities, for instance, C and D both have carbonyls in from different functional groups, but nevertheless, these usually appear around 1700, and we've got sort of a glaring gap here without any big peaks between 1500 and 2000. That really quickly tells us that it isn't either of these carbonyls. And then in compound A, though we would have this big peak at about 3,500, we definitely wouldn't have this peak here due to the nitrile functional group at about 2,300. So the answer here is certainly B.